Report PHI de-identification in Clinical NLP, a precise guide. Why does de-identification deserve a clear public report? First, it protects patients by removing PHI-like names, dates, and contact details, reducing re-identification risk. Second, detailed reporting enables reproducible clinical NLP. Others can rerun your pipeline, compare models, and trust the results. Third, transparency builds trust with reviewers, clinicians, and users who need to know what was removed and why. Finally, it supports legal and ethical compliance under frameworks like HIPAA and GDPR. When your process is visible and auditable, you show respect for privacy, strengthen scientific rigor, and make real-world deployment safer. Start by scoping the task. Specify exactly which PHI types you remove: names, addresses, dates, IDs, locations, and which you keep. State the use case and domain: clinical notes, lab reports, messages, or mixed sources. Each has different cues and risks. Describe inputs and outputs, what format comes in, raw, text, JSON, and what leaves. Redacted text, tags, offsets. Clarify the document unit, sentence, note, encounter. Make assumptions and exclusions explicit up front. For example, we do not mask provider names, or ages over 89 are bucketed. Clear scope avoids confusion and aligns expectations. Be open about data. Explain the dataset source, institutional notes, shared task corpus, and any access constraints or approvals. Describe your annotation schema, the PHI label set, definitions, and examples from the guidelines. Report annotator expertise and training, clinicians, professional annotators, or mixed teams, and how many annotators labeled each document. Provide IAA metrics like kappa or F1 to show consistency and outline the adjudication process for disagreements. Include small, anonymized examples that illustrate edge cases. Transparent annotation practices make your results credible and reproducible. Walk us through the pipeline in words. For example, pre-process text. Run rules for high-precision IDs. Apply ML for names and locations. Then post-process to merge spans and redact. State your components: pure rules, pure ML, or hybrid. Detail the model: encoder, e.g., a clinical transformer, features, case, context windows, training data size, and hyperparameters, learning rate, batch size, epochs. Note any external resources, gazetteers, regex libraries. Document versioning for code, models, and resources so results are traceable. A clear architecture lets others reproduce and stress test your approach. Map your labels to standards like the HIPAA 18 identifiers so reviewers know what's covered. List exact label names and definitions, e.g., person_name, date, age_over_89, contact, location, ID_number. Define boundary rules, include titles with names, attach trailing punctuation. For overlapping entities, state tiebreakers. Does a hospital name inside an address get organization or address? Provide tricky examples. Initials like JD, partial dates like spring 2023, ages 90 plus, room numbers that look like IDs, or clinic names that resemble people's surnames. Precise tagging rules prevent annotation drift and evaluation confusion. Report, precision, recall, and F1. both micro, overall, and macro, per category average. Define matching rules clearly. Exact match for strict evaluation, and partial match to credit near misses when spans slightly differ. Always show per category results. Strong overall F1 can hide weak performance on rare but sensitive labels, like IDs. Include confidence intervals via bootstrapping and perform error analysis with representative examples. False negatives on rare IDs, boundary slips on dates, or over-redaction of clinical terms. This level of detail helps teams prioritize fixes and assess deployment risk. Explain the nuts and bolts. Describe pre-processing, tokenization, sentence splitting, normalization, and post-processing. Span merging, redaction style, like brackets or surrogates. Share heuristics for dates, relative versus absolute, rare ID patterns, and safe surrogates that preserve format without leaking PHI. Provide runtime stats, hardware used, and throughput per document so teams can plan capacity. Cover security. No logging of raw PHI, encrypted data in transit and at rest, access controls, and audit trails. Operational clarity ensures the system is not only accurate, but also safe to run in real environments. Bundle everything people need to rerun your work. Release artifacts, code, trained models, configs, and seed values. Document data governance. Who can access the data set, approval steps, and any synthetic or surrogate alternatives? Reference the reporting template or checklist you followed so others can mirror your process. State limitations honestly. Domain shift across hospitals, bias toward well-represented names, or weak performance on handwritten notes. Discuss generalization risks and when human review is required. Good documentation turns a one-off experiment into a dependable, reusable clinical NLP asset.